Welcome to Spring LIB.
Okay, chapter 15, problem 1. We're given this equation for the motion of a brake drum, where theta is the angular position in radians, and t is the time in seconds. Part A, we're asked to find the angular velocity at time t equals 2 seconds. We can get the equation for angular velocity because that is just the derivative of angular position with respect to time. So theta dot. If we take that derivative, we get 36 minus 3.2 t. Now, if we plug in t equals 2 seconds, that leaves us with 36 minus 3.2 times 2, which simplifies to 29.6. And our units are radians per second because we're dealing with angular velocity. So that's the angular velocity of our drum at t equals 2 seconds. Moving on to part B, now we need to find the number of revolutions executed by the drum before it comes to rest. So a way to do this is to first determine when it actually comes to rest. In other words, find the time t at which our angular velocity, theta dot, equals 0. So let's set our equation for theta dot equal to 0. And then just solve for t. And we get t equals 11.25 seconds. That is the time at which our drum comes to rest. Now, we're not done yet. We need to find how many revolutions are executed over this time of 11.25 seconds. And we can do that first by finding the change in angular position from time t equals 0 seconds to t equals 11.25 seconds. So we'll let theta 2 represent the angular position of our drum at 11.25 seconds, and theta 1 represent the angular position at 0 seconds. So now let's go back to our original equation for theta and plug in these values for t to find our theta 2 and theta 1. So for theta 2, 36 times 11.25 seconds minus 1.6 times 11.25 squared. And that simplifies to 202.5 radians. Now we'll do the same for theta 1, but theta 1 is easy because t equals 0, which means both of these terms end up simplifying to 0. So theta 1 equals 0, and therefore our change in angular position is 202.5 radians. Now we can convert this to revolutions. We know there are 2 pi radians in 1 revolution. So if we multiply our 202.5 radians by 1 revolution over 2 pi radians, our radian units are going to cancel out and we'll be left with revolutions. And we get 202.5 over 2 pi, or 32.2 revolutions. And that is how many revolutions are executed before our drum comes to rest.